So for number 13, they want us to find at least 10 partial sums of this series right here, which is the sum from 1 to infinity of 1 over root n minus 1 over root n plus 1. So what I've done is I've made this table where it goes from n is equal to 1, 2, 3, and so on until 10. And in the second column, an, I've put the sequence. So basically it is 1 over root 1 minus 1 over root 2, and then 1 over root 2 minus 1 over root 3, and so on until the last one, which is 1 over root 10 minus 1 over root 11. And so I've gone ahead, I've put these in and I've calculated their values. And now it wants the 10 partial sums. So the first sum is just the first sum of the first term, right? So it's just the same thing, 0.29289. The second sum is going to be 0.29289 plus the second term here, which is 0.12976. And so we're summing up the first two values. For the third sum, we're summing up the first three values, so these three decimals here. For the fourth sum, we're summing all of them up until the 10th sum, where we're summing all these values of the sequence from 1 to 10. So I've gone ahead and I've put in this table, and now they want us to graph both the sequence of terms and the sequence of partial sums on the same screen. So what we're going to do is we are going to make a graph right here, like so, where this one is for n is equal to 1, 2, 3, 4. Actually, let me improve this a little bit. So let me just zoom that in. That is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are my values of n. And on my y-axis, let's see what I'm going to do. I'm going to put that is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and lastly 0.7. Okay, so once I've done this, they want us to graph these the sequence and the sum of partial terms. So I'm just going to make a key here where the yellow one is going to be our an, so which is our sequence. So for n is equal to 1, we have 0.29, so about here, very close to there. For n is equal to 2, we have 0.112, so already there's a steep decline. N is equal to 3, 0.07, so roughly here, and then 0.05 for n is equal to 4. For n is equal to 5, 0.03, and then we have 0.03 as well, but slightly lower. Let's see, for number 7, we have 0.02, so way down here, and then 0.01, sorry, for 8 is 0.02 as well, and then 9 is 0.01, and lastly 10 is also 0.01. So we can see that these get very, very small really fast. And now we're going to graph our Sn, which is our sum. So this is going to be here our Sn. So the first one is going to be at that same point, right, which is 0.29. And then we're adding the points. So now we're adding the second point to the first. So that's going to give us 0.42, so about here. And then we're adding the third point to the previous sum. So that's going to be 0.5. And then we have 0.55. 0.59, which is about here. Let's see what else. 0.62 for the sixth sum. The second sum we have 0.64. The eighth sum we have 0.66. The ninth is 0.69, and the 10th is also 0.69, but slightly above, right? So we can see that the blue here represents all the sum of the first 10 terms, and the yellow represents the first 10 terms. So it's asking us, does it appear that the series is convergent or divergent? Why? And it does appear that it is convergent, right? And the reason that it appears is because the terms, they get smaller and smaller and smaller. So eventually, as we keep adding these terms, it's like we're going to add 0. And so it appears that the sum is going to stay put at a particular place. So what we're going to do here is find the sum, right? And if we remember that this is the formula here. Now, what happens when we're taking the sum? There's a curious pattern that happens that I'm going to, we have the first here, right? And then when we add the first and the second, well, we have minus 1 over root 2 plus 1 over root 2. So those are going to cancel out. And then when we add the second and third, we have minus 1 over root 3 plus 1 over root 3. And then when we add the third and fourth, it keeps canceling out, right? And so we can see that it does this kind of like this diagonal canceling, where if we add one more term, it'll cancel minus 1 over root 6 with plus 1 over root 6, and then this will cancel out with that, and then this will cancel out with that, this will cancel out with that, this will cancel out with that, and we're left with the only two terms that were left is this 1 over root 1, which is the first, and the last one, minus 1 over root 11. So we can see here that in the sum, all the rest is going to be canceled out, right? So we can say here that our S of n, as n goes to infinity, well, we're going to have just the first term, which is 1 over root 1, right? Minus 1 over root n plus 1. So when we take this limit here, actually I should put here, this is our S of n, right? Which is just the first term minus 1 over root of n plus 1. And then when we take the limit as n approaches infinity, what we're going to have here is 1 divided by root 1, that's just 1, minus 1 divided by infinity plus 1, right? So minus 1 divided by infinity, that's going to be 0, because they were like dividing by a very large number. And so this is going to be equal to 1. And so we've shown mathematically here that the limit is going to be 1, the limit of the sum. So it means that the more terms that you add, your sum is going to get closer and closer and closer to 1. And that is it for number 13.